Engineering is changing faster than ever. It isn't a future, it's already here, shaping design, automation, and complex systems. How can young engineers in Europe make smart career choices before technology outruns the classroom? Today we are talking with Batyr Annaiev, founder of Fence Engineering, an international engineering firm with its own R&D, i.e., education and global competition. Let's dive in. Tool or transformation? Is AI just a tool for engineers or it's reshaping a whole industry?
It's quite a sensitive question. You know that, to be honest, AI has already stopped being just another piece of software for engineers. In industry, it's becoming an infrastructure layer, like electricity or once was, and later the internet. Yes, at that level, of an engineer's hands, it's a tool. Faster calculation, faster design, iterations, quicker anomaly detection. But at the level of the entire plant, AI starts reshaping the logic of how we design, commission, maintain, and manage risk. I look at it very pragmatically. If you are responsible for automation and power supply, your biggest enemies are downtime, incidents, human errors, and the classic, we don't really know what's happening. AI, data, and digital models do one crucial thing. They turn a facility into a system that can be explained, predicted, and scaled repeatedly, instead of relying on heroic firefighting.
According to the World Economic Forum, AI could add 20 trillion to global GDP by 2030, becoming one of the most powerful economic forces of the century. Where do you see AI already changing projects and engineering's daily work?
Yes, it's at first, before I give you an answer, we should admit that engineering is routine work. Specifications, comparing alternatives, finding clashes, validating logic, incident analysis. Things that used to take weeks can now be done in hours. But the key point is the engineer will still owns the responsibility. AI doesn't remove accountability. Second, real-time operation, optimizing operation modes, anomaly detection, predictive maintenance, energy efficiency. In industry, this is always about money and trust. If you lose tempo due to unstable power supply, for instance, or energy constraints, you lose contracts. We talk a lot internally about controllability as a new standard. And to make it tangible, in our grain logistic and port terminal cases, systematic automation of the loading unloading process delivered around 90% faster vessel loading and about 70.5% energy saving in a specific implementation. On another side, comparable gains in the throughput and energy efficiency that is kind of impact people on the ground feel immediately. Fewer stops, fewer manual decisions, more predictability.
And it's a tricky question. Which three skills should young engineers start developing today to stay ahead in future?
Okay, let me rank all the skills and identifying skill number one. It's really known as system thinking, where we're talking about process and constraints. Understanding the process as a bottleneck, risks, safety, energy, and be able to see what whole facility, not just one cabinet or one piece of code. The second skill is data literacy for engineers, not becoming a data scientist, but knowing what data is needed, where it is generated, OT, for instance, how data quality works, how to validate models, and how to quantity impact in kilowatt hours or ton hours uptime. And the last point, deployment discipline plus OT, cybersecurity, hygiene, AI, industry is only valuable. It works every single day. That means versioning, testing, monitoring, resilience, security, access control, otherwise, and smart model becomes a risk generator.
How do you think in AI-driven world, what matters more, this deep technical expertise for engineer or broad system thinking?
I'd put it this way. The future belongs to T-shaped engineers. You need real depth in at least one stack drives, PLC, SCADA, power system, safety, process control. Otherwise, you can't tell a nice slide deck from a working solution. But without system thinking, you won't deliver that the market now rewards integration, a digital control loop, a digital twin, and virtual commissioning, and a true industrial data loop. In real EPC projects, design, manufacturing, installation, commissioning, service, the value is created at the interfaces. And that's exactly where strong engineering teams win.
You work with students in different countries, Poland, Ukraine, Estonia, and I want to ask how can these young European people make smart career choices in a global European market?
Thank you for this question. I'd recommend choosing less by job title and more by the environment where you will grow. Look for places that has real sites, not just presentation, ownership and accountability for results. International standards and delivery practices, a culture of pilot scale. A very honest filter is this: if the company can turn technology into a repeatable deployment product, you will grow faster than in environment of endless approvals.
Should you start local or aim an international career right away?
The best path is local hands, global mindset. Local projects give you the most valuable thing: contact with reality, power constraints, reliability issues, human factors, logistics, weather, raw materials variability. These are things you don't learn from textbooks. At the same time, I'm a big supporter of early internationalization in terms of standards and thinking. English, documentation, discipline, IEC, ISO approach, cybersecurity, hygiene, and project culture. Today, an international career often starts not with the relocation, but with how you work and what you can consistently deploy.
The World Economic Forum reports that 41% of companies accept job displacement to AI by 2030, but 77% plan to reskill employers for AI collaboration. Batyr attend the World Economic Forum in Davos every year, giving first-hand insights into global AI and tech trends. Tell me, please, what is the main lesson about AI and tech development from Davos for you in this year?
I have been visiting Davos for the last 4 years, and talking about last Davos, my main takeaway is very down to earth. In Europe, the issue is not longer whether we can create technology. It's the speed at which we can turn it into deployment. Too many solutions get stuck in approval cycles and risk aversion. And the second big point is trust and security are no longer optional. For AI, they are part of core product. Another important theme I strongly agree with: in industry, the winners are those with access to real assets, real data, and real infrastructure, so they can move quickly from pilot to scale. That's why the idea of industrial sandboxes isn't a buzzword, it's a practical necessity.
How do you think, where do Ukrainian and European engineers fit in global tech race?
I see a strong position with one condition. It's strong because Europe and Ukraine have deep traditions in engineering, manufacturing, energy, and operational discipline. And talking about Ukraine also developed engineering under pressure. working under instability, constraints, and risks. The condition is simple. You win not with an idea and not with a pilot, but with a scaling. Globally, ecosystems win when they provide first access to industrial data, facilities, and infrastructure, and when they can turn implementation into a repeatable delivery model. Finally emphasizes, yes, I increasingly see AI as a new infrastructure, like the power grid or communications. Whoever owns the data, compute, security, and deployment practices will set the pace.
If you were 20 today, where would you start?
Thank you for this classic matter. I would go where there are real facilities, and you can touch the process, literally. Process production, terminals, energy, heavy industry. The sector is less important than the reality. In parallel, I would build a double stack. Classic OT fundamentals, PLC, SCADA, drives, safety, networks, what else? Basic power engineering, and a digital layer. For instance, about some language of software development, Python, data, simple models, analytics, digital twin thinking, cybersecurity, hygiene, and third, I'd learn early what the market truly values, not just inventing, but deploying and repeating it 20 times. Because the industry of the future is built by deployment, not by presentation.
AI raises the bar. Those who start today will shape tomorrow's tech economy. Want to stay ahead in AI and engineering? Subscribe for insights from top innovators.